to interpret the solution and to see exactly what goes on, we first look at the critical expression, which is 1 minus e to the negative t over rc. Of course, we just multiply this expression by VSC to get our solution for the system, so that if we get the graph of 1 minus e to the negative t over rc, we can just relabel it in terms of VSC, as we'll see in just a minute. So, first of all, the graph of e to the negative t over rc looks like this. You should be well versed in this graph. You should have encountered it many times in calculus and other courses, but in case you're not all that familiar with it or not that all up on it, the graph is going to be decreasing because as t increases, this exponent decreases, and the exponent then, as t approaches infinity, approaches 0. When t equals rc, we have e to the negative 1. So that e to the negative 1, or 1 over e, if 1 is here, 1 over e is here. E is a little less than 3, so 1 over e is a little more than 1/3. So this is a little more than 1/3 of this, and that's the value that the graph will have, that our function will have, when t equals rc. So this whole rc thing is important. That's called our time constant. rc is the time it takes to fall to 1 over e of our value, and that occurs between any starting at any point on the graph. We will always fall by factor 1 over e in time rc. Okay, the half-life is also important, and you have done that. You can work that out. You see that this occurs when negative t over rc is approximately 0.7, so that this half-life will be about 7/10 of rc. And of course, the half-life occurs when the function falls from 1 to 1/2. And right here it is. Here's your half-life. Here's your time constant, your rc. You want to store that away, and you want to have a good visual picture of that. It's extremely important. Now, if we want to do 1 minus e to the negative t over rc, well, we just flip this graph upside down and add 1. So that where this graph has value 1, if it's flipped to give you the negative t, e to the negative t over rc, this is going to be negative 1, and if we add 1, that's going to get us up to 0. And as this graph approaches 0, the reciprocal graph is also going to approach 0, which means that the resulting graph is going to approach 1, and it's going to approach 1 in the same way that this approaches 0 as t approaches infinity. And you should be familiar with this from pre-calculus. This is something that should be done very thoroughly in pre-calculus, but isn't always done. Matter of fact, I would say most students who have pre-calculus would find this to be quite mysterious. Okay, most pre-calculus courses. So, what should be done? Okay, now that we got the graph of 1 minus e to the negative t over rc, all we've got to do is multiply that by VSC, and we have the graph of 1 minus e to the negative t over rc. Well, I can multiply this by VSC by simply changing my labeling here. If I multiply 1 by VSC, I get VSC. So now the asymptote is VSC, which is the point at which the charge on the capacitor creates a voltage that's exactly equal and opposite that of the source, if you go back and understand what all this means. And of course, then we have, instead of 1 over e, that's going to be VSC over e. And you can't read that, but it says VSC over e. Everything, every y value, every y quantity here is going to be multiplied by VSC. So that down here you're going to have VSC over 2. And that's going to be your half-life. Your RC and your half-life aren't affected by this because, again, everything here is multiplied by VSC, and of course we probably want to multiply our function now, my VSC. So here's a graph of VSC times 1 minus e to the negative t over RC.